It is 2 o'clock on the West Coast, 5 p.m. on the East Coast, and we're going to get the meetup started for Thursday. How can it be November 7th already? This is just crazy. So welcome to the Vancouver Power BI Modern Excel User Group Meetup, the Thursday, November 7th edition. This is our Excel edition of our meetup for this month. I just want to start off by saying a big thanks to the sponsors that make this thing happen. So SkillWave is the training company that I, Ken Pulse, if you don't know me, run with my partner, Matt Allington, where we teach you to be awesome at Power Query, Power Pivot, Power BI, DAX, all the good stuff in dimensional modeling and things like that. If you haven't checked out our training, you should definitely do so. There's some great programs there. SkillWave is a division of Excel Guru, which is my company as well, which is also the distributor of the Monkey Tools add-in. Our next meetups that we have coming up in a couple of weeks, we are going to be welcoming Jocelyn Porter and Daniel Sepsi to talk about Power BI performance troubleshooting. And then I can't believe it's already time for this, our last meetup of the year will be on December 5th. And we're going to be welcoming back our good friend John Peltier, who is going to be talking about something we just haven't really determined exactly what yet. So I feel like it's going to be a dynamic something, but there we go. So looking forward to both those. They should both be open for RSVPs now, so don't miss your chance to come to those as well. Just a quick note on Monkey Tools. The last release of Monkey Tools that I did was in October. This has added some better license management to the project. It's added a new DAX indenter that actually has options, so you can put commas at the beginning of lines or the end of lines or force comments to lines and things like that. You can also indent your DAX now in both BiblioMonkey and in our DAX Sleuth. It'll happen for you automatically, but if you do want to just write something that isn't indenting, you press Control-I, and in both of those, it will indent it right away, which is kind of cool too. Naturally, of course, there's always bug fixes that go into this. I've got more things planned, obviously, for the new year. I just haven't had a chance to really work on this without the things that are going on at this time frame. So if you'd like to get into a free course where you can learn how to use Monkey Tools or even learn what it's all about, you can do that at the URL that you see on screen here. We do host a completely free course at SkillWave on how to use Monkey Tools, which will also tell you what features in there are free, which are not, all those kind of things. So you can even start with a free version of Monkey Tools as well. Just to let you know, our penultimate kickoff dates for our Excel Fundamental Academy and our Self-Service BI Academy are coming up on November 13th. That's our next kickoff call. The Fundamentals Academy is a great program for you if you are looking to fill in some knowledge gaps, learn about some formulas and how to work with pivot tables and Power Query, things like that, data visualization. Maybe you or someone on your team feels that they're self-taught and needs a little bit of help in just filling in those gaps. This is what this program is all about. It also gives you access to my semi-monthly Ask Ken Anything sessions where we can help you apply those techniques to your own work. Like the Fundamentals Academy, our Self-Service BI Academy, which is my sort of flagship training product, also kicks off on November 13th. This is for people who are already using pivot tables but want to master Power Query, Power Pivot, and Power BI. We put all these things together into a pretty robust course. There's a ton of stuff inside this. Again, access to all of our Ask Ken sessions, my books, Monkey Tools, all my good stuff is inside this one here. So if you haven't checked this out or you really want to up your game, you can definitely check it out at the link below here. By the way, this slide deck is PDF'd and uploaded to the Meetup site, and all of the links are inside there already. This meetup, as all meetups, will be recorded, is currently being recorded, and will be posted on the SkillWave YouTube channel within 24 to 48 hours. I just need to do a little bit of editing before uploading. Once it is available, we will post in the meetup chat, so you'll know that the link is available. Of course, if you subscribe to the channel, you get notified automatically without even having to read the meetup channel. The last thing that I'm going to say before I step aside here and welcome our presenter is if you'd like to get involved and come and do a presentation for us, we would love to have you. Just fill out this quick little survey here. Tell us who you are. Give us your email address. We'll get in touch with you and we'll get you on our stage. And now I think that's it for my stuff. So I am pleased to welcome my friend Dim Early, who is going to be talking about LET and LAMBDA functions. So Dim, welcome to the show here. It's all yours.
Thanks for having me.
Absolutely.
All right. I am going to jump straight into sharing my screen. I guess just to give you a sense of where I'm going with this, I'm going to sort of start off with a very, call it gentle introduction, because I have a sense that Lambda has this, or like custom functions, which is Lambda in Excel, has this like very fearsome reputation, even among like very experienced modelers, that there's this sense that Lambda is like crazy out there. So we're going to start off with like the most, gentle introduction to, you are closer to writing your first custom function in Excel than you think. And then I'm going to show you how to, put let in the mix and do some totally crazy things with it. But all right, let me share my screen and we can get started.
Perfect. So, I can see it. Looks great.
All right. So writing your first custom function, just the basics to begin with. Forget about custom functions. What is a function? Very simply, functions turn inputs into outputs. The easiest way to think about this, so like take an example like the sum function, inputs one or more numbers or ranges, outputs the sum of all the numbers. If you start typing a function in Excel, the little autocomplete thing will show you basically this thing on the right. It'll show you whatever, if you type X and scroll down as you go through like X match, X lookup and so on, it'll tell you next to that in a little like tooltip, basically this thing. It'll describe what the function does, and that's the output. And then once you hit tab and it gives you the function name and an opening bracket, then it'll give you the list of inputs that it wants for that. So you can, for any Excel function, you can see these two pieces. So I, for a slightly more complex example, the PMT function takes the rate, the number of periods, present value, optionally takes some other things as well, and outputs an equal mortgage payment amount for each period over the life of a loan. Take another one, the weighted average function takes a set of values and a set of weights and outputs the weighted average of the values. The only thing that's different about this function is that it's not a native Excel function. So that's going to be our sort of first sandbox example. I don't know why I put this after that rather than before, but anyway, this is what I was talking about earlier, is like there's this association, and it's not completely unfounded, that is, Excel goes from simple to advanced to crazy to Lambda, and Lambda is like the most extreme kind of crazy out there. And there's some examples of the madness that happens under Lambdas, most of which we're not going to touch on today. I encourage you to think about it in a totally different way, which is a sort of 2x2, which is to say your formulas can be simple or they can be complex, and they can be just as a regular kind of native function typed in, or they can be a Lambda. They're pretty independent. The one thing I will say is there's kind of an extra box over here, which is there is a degree of complexity that you can only reach through Lambdas. But for today and for your first like 6 to 12 months to forever working with Lambdas, don't worry about what's over here. Like you can do really simple Lambdas, including the example we're going to look at right now. So let's talk about syntax. Weighted average function. It takes values and weights, and this is how you would write it out just in kind of natural Excel language. I'll actually show you this as an example in a spreadsheet in a minute, which is, just make these named ranges, like name the values, name the weights. Then you can just say sum of values times weights divided by sum of weights. That is the weighted average function. So how do we turn that into a Lambda? Just that. So you say Lambda is just the name of the function. The arguments it takes are first the inputs to the function, and the last argument is the calculation. So you say, I want a function that takes an argument called values and an argument called weights and does this stuff with them. And this stuff is written exactly as you would write any other Excel formula, except that instead of referring to cell ranges, you refer to these names from up here. So that's it for the PowerPoint. Let me come over to Excel. So like I said, same thing, just in the grid, you can see it. Here's our units sold and our sales price. So, if you just take a straight average of that, you get not the right answer because, you sold more of, let's say, these few ones up here at higher prices. You sold fewer of these ones down here at lower prices. So if you weight according to the number of units sold, you get a weighted average. And so that looks, again, exactly like sum of this range times this range divided by the sum of this range. That's your weighted average. Then you can just give those names, weights, and values, and you can define your function. So the inputs, again, values and weights. The output, sum of values times weights over sum of weights, converted into a lambda, exactly the same as before. And then the other kind of thing that's slightly confusing about lambdas is, so lambda is a function, and so all of this from the opening bracket here to the closing bracket here is a function call, but what that returns is a function. And so then you have another set of brackets after that to then provide it with the arguments. So we're saying the first argument is values, so we select the values range. Second argument is weights, so we select the weights range. But you also have the option to then take that lambda and put it in the name manager, give it a name like average weighted, and then you can just call it like any other function, weighted average of these values and these weights. So I can just type in average weighted, and it tells me, okay, I'm looking for values, then I'm looking for weights. And the way that you do that is just taking this piece here, open up the name manager, and I've got a bunch of different things in here, but it's this one here. And you can see I've just pasted that lambda value weights, some value times weights over some weights in there. And then I can use that exactly like a native function. And I guess before I go any further, does anybody have any kind of, wait, hang on, that doesn't make any sense reaction to this? My hope is that this is the piece that makes it feel friendly and welcoming before I, lure you in and then show you much more complicated things. But that doesn't work, of course, if this doesn't seem like it makes any sense to start with. So I want to give you a chance to shout.
I apologize. Could you show us where you pulled up the name manager again?
Yeah, so I just do it by pressing Control F3. There is something, I think it's on the formulas. I don't actually know where anything is on the ribbon because I just use keyboard shortcuts. Yes, here. So on the formulas tab, you can click Name Manager, and then you get that pop up there. And then you can just say new, give it whatever name you want, and then paste in your lambda here. Yep.
So,
I would just say test it. Sorry, go ahead.
I was just going to ask a quick question. You can use this across any new worksheets as a named function then?
Yes. So it's, if you put it in the name manager, then you need to, like, that named function resides in this workbook, but right. It's very easy to copy to another word. So like if I just start a new file here, and let's just say I come and grab these things. And just, oops, sorry. Paste them in there. Then I can just come over here and copy any cell that has that function in it, bring it over here. So you can just see new file, nothing in the name manager. Then I, oops, sorry, I gotta grab it again because I opened up. Paste that in there. Don't worry about the references. Now we've got the weighted average function in here. I'll talk about other ways to share them between files as well, but then I can say weighted average of these are the values and these are the weights.
Thank you.
And you get the same thing. Yeah, any other questions there?
Yeah, I was going to say, I've always found the fact that you can't just make them globally available is sort of takes the shine off them a little bit, unless you're going to disagree with me.
No, I don't disagree with you. I will say a couple of ways around that. One is if you have lambdas that you use regularly, pardon me, then you can, like, I've got a pinned set of lambdas here, so I can, anytime I want, I can kind of open that file and import lambdas from there. So I guess might as well talk more about sharing while we're at it. So if you have just one function you want to copy over, you can just, exactly like we just did now, just copy any formula that has the function into the new workbook, and the function definition comes with it. If you have many functions, you want to bring them all. So I mentioned I keep a collection of lambdas I use regularly. You can copy any sheet from that workbook into any other sheet. And if you're used to named ranges, you'll know that it brings all the named ranges with it. But in particular, any named ranges that are custom functions will also come over. So if you have, let's say you have a set of, 5, 10, 20 lambdas that you use regularly, if you just keep them in a file, in it to your saved files, and then anytime you want to have them in the file you're in, open it up, and there you go. The other option, if you want to get a little more creative, is you can store them in your personal macro workbook, and then have a macro in your personal macro workbook that imports one or a set or whatever number of them into it. There's also a whole longer topic, which I wouldn't dream of trying to cover today, of Lambda sharing through gists. So if if you're used to kind of non-Excel programming, you're probably already familiar with the idea of a GitHub gist. There is an Owen Price video, which, and let me just grab this, I'll put the link in the chat, which I recommend. Hang on, where is the chat gone? I don't know how to do the chat when I'm sharing my screen. Hang on, let me just stop sharing for a second. There's the chat. And boom. Okay, that is just a link to Owen talking about where do I go on screen? About sharing with gists. It's a pretty cool way to do it. The other thing worth mentioning is I saw Ken mention in the chat that Monkey Tools does this. There's also Eric Ohm has a very cool tool called OA Robot that is good for. This is it here. It's just in public beta at the moment, but check out, I think it's oarobot.com, or just search for OA Robot, and you can find that. It's like a micro automation tool, but it's very Lambda friendly. So it's a great way of kind of curating collections and bringing them together from different places. Yeah, so that's the sort of basics. The next thing I was going to show you is just a few examples. I'm not going to kind of talk about how any of these are written. It's more to give you a sense of some very different things that you can do with a set of lambdas. So, a simple example, Excel now has a text before and a text after function. So lots of people have had the thought, the way that I tend to use this is actually to get text between X and Y. So, it's very simple to write a text between function that just says, take the text that comes after this delimiter, and then from there take the text that comes before this delimiter, and it just lets you extract things. It's, for example, if you use the cell file name function to get the full path of your file, it comes out looking like this. So if you want to extract the name of the workbook, then text between is a handy way to do that. So you can kind of wrap this around cell file name, and it'll give you the name of whatever workbook you're in. You can also just make this whole thing into its own lambda that takes no arguments and just returns the workbook name. So that's one thing. Here's another thing. Again, Owen Price, and he shares his gist here. I'll post the links to some of the gists in the chat in a minute as well. But this is just a simple one for, say you have a bunch of pairs. Sorry, a bunch of two lists of attributes. So like here, colors and months, and you want all the combinations of those. So like, for example, if you're modeling by region, by product, or something like that, it just has a simple custom function that says, give me the two lists, and I'll output all the possible combinations of those. If you're old like me, you probably remember a time when you basically said, okay, well, let's see, there's 7 items in this list, so I got to make 7 copies of this list, copy, paste, 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 and then there's 12 items in this list, so I got to make 12 copies of this list, paste, 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 and then sort one of them, and then it would give you something that was basically this, but in a very slow and manual way. This is much easier. This one is just, I put it in solely because it's such an interesting creative use. So you can, the idea here is that you give it, it starts with like a list of colors in RGB format and names, and then you give it an RGB code for any color, which like you can pull out of a cell color with VBA. But say you want to get this in human readable format, then you can use this to say RGB to color name, and it basically does a least squares matching to say what is the closest color of the whatever 145 colors in here, and you could add or remove or change or whatever for that set, but it says what is the color that comes closest to this, and it'll tell you, okay, this is closest to antique white, this is closest to light green, closest to orchid. I just thought that was a really kind of surprising, creative way to use Lambda. This is one that I use for financial modeling. You give it, either a start year or a start date and a number of periods, and it'll give you a sort of flexible model that says, okay, here's the period start date, the period end date, the year number, the month number, the quarter number, the quarter name, and then depending on what you want, you can say there's like 3 months per period, and now. What was I saying? Oh yeah, just that you can change. So like right now you can see it's doing 1st of Jan, 1st of Feb, 1st of March, 1st of April, and then to the end of the month. But you can also tell it, I want, 3 months per period, and then it'll go from the 1st of Jan to the 31st of March, and then the 1st of April to the 30th of June. Or you can say you want 6, 12, whatever, and you'll see that some of the relevant, the month name is not applicable if you're doing 12-month periods. It's only applicable if you're doing one, so those drop out. You can also tell it specifically to, these are optional arguments here, to tell it specifically to add or remove certain things. I think I use a slightly even crazier version of this now, but anyway, that's the one that I have in my example workbook. And then one more kind of financial modeling one, just to kind of turn the dial up to 11, so to speak. This is a Craig Hatmaker one. He does lots of cool stuff on financial modeling with lambdas. So here you've got 4 different sets of loans. So a first home, second home, car, and a boat. You've got the principal amount of the loan, the APR, the term in months, and the start date. And you want to build, a debt schedule for each one of these according to your timeline that goes out to whatever 30 or so years later when these all run out. And this, so the timeline is one thing, and the labels and the totals are one thing, but like this, everything in this block is one single formula, which takes as its arguments the list of principals, list of APRs, list of terms, list of start dates, and then builds these entire schedules, and does it in a flexible way so that if you say, wait, actually, I also want to buy a ring for, I don't know, $1 million, and that's $100,000, $1 million at a 25% interest rate, and it's going to be paid off in 12 months, and it starts, whatever, let's say today. And obviously I need to extend the formatting down to make that not look hideous, but you can see that it's already kind of built out. Sorry, I need to have it as a month start date so that it doesn't break. But anyway, you can see that it's already kind of built out there. Yeah. So that's just,
Tim,
again.
Tim,
yeah.
Anthony is asking, what's the formula for the TL function?
The TL function is, let's take a look. Actually, hang on, sorry. A good place to look at a large, complicated formula is if you have the Excel Labs or Excel Garage plugin. Just makes it a lot easier to look at these things. So we're going to look at it over here. Just got to move that little doodad. So let's go look at TL. And let's, my screen is so small, it doesn't look great, but anyway. So we've got, so this is a LET. We're going to be talking about LET in more detail in a minute, but if you're Ken, I know you said a lot of Power Query users here, so if you're familiar with M code, then the idea of a let is not going to be uncommon to you. It's just basically you define a name, so it's saying let stclean be this calculation. So it's saying if the start is less than 3,000, then give me a date, which is that year and the 1st of January. Otherwise, give me the date. So in other words, it's the same function whether you give it a starting date like the 7th of November 2024, or you just give it a year like 2024. So this is just turning that into a date. Then period clean, again, if the number of periods, if the number of months per period is omitted, then it's 1, otherwise it's the period. So that's just lets you have an optional argument here, so you don't have to specify the number of periods. Then there's a sequence, which is the number of years times 12 divided by the number of months per period. So that just tells you how many columns you're going to need. And sequence just makes the numbers from 1 up to that number of columns. Then start of month is EO month from the start date by the sequence times. This is basically just calculating all the month end dates. And then it is just, the output is just stacking all of these things together. So it's saying stack the sequence, the start of month, the end of month, the year of the month of the month. Then this is just calculating the quarter, which is round up the month over 3 to 0 decimal places, and then the quarter name, which is the year of the start of month plus the letter Q plus the quarter number. And then it's saying filter out based on all these things. So like basically if you put in a 1 for any of these arguments, it will remove them. So yeah, you can say like, I don't want the month start, I don't want the year number, and I don't want the quarter number, and it'll just filter out each of those. And then slightly more complex logic for the month number, quarter number, and quarter as text, because it's saying, if the number of months per period is greater than 1, then it doesn't make sense to show a month name or a month number because that's not applicable. And similarly here, if the number of months per period is greater than 3, then it doesn't make sense to show a quarter name because there'll be multiple quarters in the period. So yeah, you caused me to get ahead of myself a little by getting into a giant example of a giant let statement here, but that's where we're going in a minute. Now, before I forget and leave this file, I'm just going to grab so these examples, aside from this one, they're all not mine. This one is mine, but they're all kind of publicly shared. So that one just came from a LinkedIn, but whoops, sorry, didn't mean to open that. It came from a LinkedIn post. So hang on, I'm just going to stop the share and put these in the chat. So that is the Alan Murray's thing about, actually, no, I think that's just Alan Murray's LinkedIn. I don't know if I have a link to the post. This is Owen Rice, GitHub. I'll say Eric. I mean, all 3 of these have great public collections, but Eric and Craig in particular just do like a kind of best-in-class job of like formatting and documenting their lambdas in a very high-quality professional way. So this is Craig, GitHub. Okay, let's get back to my screen share. All right, so anyway, that's just some kind of general examples. One sort of common theme of the more complex, like the weighted average, the text between, these are pretty simple things, but a common theme of the bigger, more complicated ones is that you're going to need multiple steps. So like, for example, with that timeline one, you need to calculate, start dates, calculate end dates, calculate years, months, quarters, etc. And if you need to do a bigger kind of complex multi-step formula like that, then LET is a great example. So the very most basic idea is, LET allows you to save repeated calculations. So, for example, if you're doing like financial reporting and you want to show, you want to display some ratio, like in this case, it's your gross margin. But, if there's a divide by zero error, then you want to show an NA, and if it's greater than 100%, then you just want to show the text greater than 100%, and if it's less than minus 100%, you want to show that as text. Otherwise, you want to show the ratio. It's a pretty kind of common use case. So you might end up with a formula something like this, and LET allows you to say, okay, I'm going to define GM to be this thing here, and then every place that I had that, I'm now just going to put GM. So you get, same formula with and without LET. This is a pretty kind of canned example, but even in this sort of very small example, it's not doing much for you in terms of efficiency, but just the fact that you have this calculation only in one place now, the reduction in likelihood of error if you update this formula later is already pretty significant, which is to say, if I come into this later and say, okay, hang on, wait, I didn't mean to point to, sorry, let me go to the one that has it live. I didn't mean to point to F9, I meant to point to F7. So hang on, let me just fix that, F7, F7, F7. And well, that is obviously calculating correctly because I'm now pointing to an empty cell. But if you're sharp-eyed, you notice that I skipped over one. So now I've got a formula with inconsistent calculations. And if you're, if you've got a branching if like this, this branch might not come up for a while. So there's every chance that you will not notice for a long time that you have made a mistake in just one of the branches. So that's why, or that's one part of why it's helpful to have, just in the same way that, if you're used to financial modeling, like one of the golden rules of financial modeling is that an assumption should only be entered in one place. So like whatever, if you are assuming that the tax rate for 2024 is 35%, then that should be entered in one assumption cell, and then everywhere the tax is calculated should refer back to that. And the reason for that is exactly the same as this, but just on a kind of larger scale. If you come back a year later, hey, we're refreshing this model, but the tax rate has changed. So everywhere that it was 35% should now be 32%. If you go through and change that in 85% of the places that you put it in your model, but you miss a few, then you have a model that is disastrously internally inconsistent and causes you all kinds of problems. So this is just a kind of much smaller scale version of that. But even within one formula, if your formula starts to get big and complex, having something like this can be helpful. But more powerful uses of LET. So number one, it lets you build more complex formulas in a way that would just not be practical otherwise. These will all be kind of easier to understand with some examples, which I'll go through in a second. Number two, it lets you make your formulas more efficient. So like this is a pretty trivial calculation for Excel, divide and subtract. But if this was, some very heavy computation, maybe it's doing, a bunch of complex lookups, or maybe it's doing, a kind of data aggregation on a large database or something like that. Then if you have to calculate the same thing 4 times to give one answer, that's a lot of waste of calculation. Whereas if you put it in LET like this, then this is not getting recalculated here and here and here and here. It's just getting calculated once up front. Which again, the bigger your data set gets, the bigger your kind of set of calculations gets, the more of a difference that makes. The efficiency point. Next thing is it lets you document formula logic. So again, it's a very small example here, but just the idea that this is labeled as, GM, you could even kind of spell it out as gross margin, already gives you some degree of kind of documentation, and you can take that a lot further. Again, I'll show you some more of that. But just, naming the steps in your LET statement in a logical way does a lot just by itself to document the logic of the formula. And then this is the one Ken and I were talking about briefly before we got on, which is performing compact calculations with the ability to recover detailed workings, because the risk, especially for let's say someone who's, you know, fresh to LET and excited by its potential, is that, you know, you squeeze your entire model down into one very, 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 very complicated formula, but then you lose the auditability. Like there are good reasons to say, well, I don't want to have, you know, every interim calculation spread out into its own cell, but there is a benefit to, in terms of auditability, of being able to say, okay, well, hang on, this interim calculation looks like this, that seems right. This interim calculation looks like that. Wait, that doesn't seem right. Let's dig in there. So I'm going to show you a way that with LET you can sort of keep the best of both worlds there, which is the combined ability to be compact and also have a sort of audit view. So funny, I was just playing around with an example before here. So this is an Excel challenge from Omid, whose second name escapes me right now. He posts challenges every few days. This was one of his sort of 5-star rated ones, so it's particularly difficult. We're not too focused on the challenge itself, but I wrote a solution to this with a LET. So, you know, start off by just defining this range is the date, so I call that DT. This range is the customer, I call that cust. This range is the quantity, I call that QT. And then you can figure out, you know, the sales. So this is about finding for each customer the 10-day period where they had the highest sales. So first you can figure out the sales for each customer for the 10 days from each date. And then you can figure out, you know, your unique customers. You can figure out your max sales by customer, the date where the max sales occurred, and then output the customers, the max sales date formatted as a year, month, day, the date 10 days later formatted, or 9 days later formatted as year, month, day, and the max sales. Again, this particular LET is not what I'm trying to show you, but just as a demonstration, if in theory you can take pretty much any LET and unpack it. So you can say, okay, this is the final output. I could replace every instance of max sales date with this calculation. And then I could replace every instance of max sales with this calculation. And then I could replace every instance of cust filter with this calculation, and so on. So I just wanted to show you, you know, this, I mean, this, if you're not used to LET, this formula probably still looks kind of large and intimidating. But if you're used to this way of reading functions, where, you know, okay, I know what this does. You know, this is a relatively kind of small, simple formula. Okay, now there's unicust. That's the unique list of customers. Okay, I know what that is. Okay, there's customer field, etc. You know, there's nothing too crazy, let's say, going on there if you're used to LET. So if you just kind of follow that process as I described, of like sequentially replacing each piece in here with the definition of the name, and then carry on, this is the formula that you get. And the funny thing is that I went through this, you know, gradually replacing, and I got to the end and realized I had made a mistake because some of it was throwing value errors, and I was looking at this wall of text thinking, how do I even find where something has gone wrong in here? But, you know, to me, again, I know some people tell me they look at this and say, like, oh my God, this is so weird and confusing. I think it has a lot to do with whether you're used to other programming languages, because, you know, nobody would ever look at a VBA module that had whatever this has 8 lines of code and say, oh my God, this is way too big. You need to break that down into 5 other modules. And nobody would ever look at, you know, M code that had 8 lines and say this is unreasonably large. But there is this kind of association in Excel with, oh my God, you've made this unreasonably large formula because it has whatever it has, 8 lines in it. But again, once you get used to reading and writing formulas like this, this is as kind of readable as most other code. To me, the comparison between, you know, this and this is, let's say, illuminating. But so there's the readability element, but there's also, if you'll see, you know, there's elements of this that are repeated. So like this sum ifs is the same as this sum ifs is the same as this sum ifs. So like the same calculations are also happening over and over and over again in the version where you just sort of spell everything out. So yeah, that's just, I've been meaning to kind of create an example of, you know, unwinding the let, and I was just playing around with this one right before we got on, so I figured I would do it in that one. Anyway, so that might give you some idea of a let. I'm going to kind of walk through that one. Like I said, I didn't want to focus too much on the details, but let's walk through another example here. So this is, I don't know if any of you guys do this. I take part in a lot of the like Excel modeling and problem solving competitions that the Financial Modeling World Cup organize. I think they're a super way to hone your skills, either as a financial modeler or just kind of Excel problem solving and data manipulation and whatever. But anyway, this is based on a case from one of their esports battles. So if you're not familiar with the format, basically you get a sort of setup and a rule set and a problem to solve, and then you get 20 different sets of inputs that you need to run it for. So in this case, it said, you know, for this schedule, what is the total distance of flights departing from or arriving in Canada? And this is what a schedule looked like. So, you know, if you're familiar with these kind of airport codes, you know, from this 3-letter airport code to this 3-letter airport code, and there's just a semicolon delimited list of a whole bunch of flight codes like that. And then you've got a lookup table to say, okay, these are the IATA codes, these are the corresponding cities. The question specifically is about Canada, so I've just included a kind of yes/no for Canada. There's only 2 Canadian cities in scope for this one. And then you've got a list of, you know, for a given departure and arrival, this is the distance. And these, I've given all of these named ranges. So this one is called city, this one is called code, this one is called Canada, this one is called dep and hour for arrival, and dist. And so you can think about, you know, modeling this out piece by piece. So you can, you know, text split this based on, sorry, I'll put it here as a row delimiter, by a semicolon, so you get the list of full list of flights. Then you could say whatever the departure code, you could say something like text before of this, what comes before the dash, and that gives you that. And then the arrival code, similarly, you can use text after, or since they're a fixed width, you could also just use, you know, left 3 and right 3 to extract the first and last 3 characters, and then you could look up, you know, look up the departure city, something like this. Look up this in code returning from city, and you do the same thing for the arrival city, and then you could figure out the distance as sum ifs of. So we're going to sum distance, this column here, where the departure city, that column here, is this, and where the arrival city, which is this middle column here, is this. And if you're not used to how sum ifs can handle dynamic arrays, that's a whole completely separate talk from today, but it's great. So all of these formulas are still kind of dynamic, so that if I sort of added to or subtracted from this list, they would all expand or contract accordingly, which makes it all quite flexible if you have, if your schedule is going to change size. Anyway, you get the idea. Then you could add another kind of lookup here to figure out is either the departure or arrival city Canadian, and then you just want to sum up the distances where one of those is true, and that's the answer to the question. So that's a sort of traditional way, semi-traditional, it's a lot of modern Excel in there, but a way to build it out. And now here's how you can do it all in a LET. And so, like, again, every individual piece of this looks very much like the formulas that you put in the individual bits. So we say let roots be text split of the input, of this input string here. Then the departure city is you take the text that comes before the dash in roots and look that up in code returning from city, exactly like we did. Arrival city the same way. Check if it's Canadian. So look up the departure city in city returning from the Canada column in the lookup table. Is that true? And same thing for the arrival city. Is that true? And then you can say distance, again, same as before, sum of this column where this is the departure city and this is the arrival city. And then ignore check for a second, and then the output is just sum of if is Canadian, then distance, otherwise 0. And that tells you, okay, bang, the answer is 117,107. But the fun thing is that this let comes with a debug mode, so I can change that to true, and it'll spit out all the same interim calculations that we were working on before. So you can say, okay, these are the routes, departure and arrival airport. Is it Canadian? This is the distance. And that allows you, for example, to say, okay, let's just double check, is Montreal always tagged as Canadian? Yes, it is. Is Toronto arrival airport always tagged as Canadian? Yes, it is. If I filter to Canadian and sum the distances, do I get 117,107 down here in the bottom right? Yes, I do. Okay, so now I've got a degree of comfort that this is working the way I wanted it to. Now I'm going to put that back to false. And that way, if you have a big complex calculation, like in this case where you had not just one of these schedules, but 20 of them, then you can say, okay, for one schedule, here is the calculation that's going to work everything out. And then if I have 20 schedules, I can calculate 20 responses. And then if I say, wait a second, one of these looks a little bit off, let's just take this, take this particular one and put it in debug mode. And then I think I also made this into a lambda. Let's see, yes, Canada dist calc lambda. So I can say Canada dist calc of, and you can see it's highlighting all of these as it would kind of highlight a range that's in the cell, because these ranges are all referenced in the definition of Canada dist calc. So that's why they get highlighted a bit like a range reference gets highlighted. So I can say Canada dist calc of that. Sorry, must be. I should have made this an optional argument, then it would have been a little smoother, but never mind. So we say debug mode is false, and it just gives me the answer. Debug mode is true, and it gives me all the workings. So then I can say, take Canada dist calc and put it in whatever 20 places next to the 20 schedules. And then if I say, hang on, one of these is looking a little fishy, I just take the one next to that, copy paste it out into an empty space where it can expand, and then change this to true, and I get my debug mode. So that's, for me, this is a great way to kind of balance the benefits of, like, you're not trying to work out what are the departure and arrival airports and which are Canadian and blah, blah, blah. You're just trying to work out this answer. Then there's a lot of benefit to being able to sort of fold away all the interim calculations. But on the other hand, if you want to go into debug mode, then it's good to be able to say, here's everything spread out exactly as you would have modeled each one individually, and look at it line by line and see the details. So I'm a big fan of, as it says here, LET combines some of the advantages of a clear spaced out layout and the advantages of compactness. I love it for that. The one other thing I would say is, if you're thinking about a LET that you can turn into a lambda, it's very, very, very easy to turn, a fairly complex LET like this into a lambda, as long as you write it in the right way. So what I would recommend anytime you're writing a LET, any references to cells, I would get those in kind of right from the start, get them in up front. This example, I am actually not following a couple of best practices in terms of lambdification, which is one, rather than just having a variable for this one cell reference and then doing other things with it, I'm starting from a text split of that. So actually a better way to do this would be to say, let's schedule be E7, and then do something here with schedule. And then down here, I've got a cell reference here. It would be better to, again, put that up at the top. So I could say something like debug is that cell. And then down here at the bottom, I can say debug. I'll explain that in a minute. So part of it is get your cell references in up front. Again, only refer to them once. So, you could easily, especially if you started off with, the routes listed out, then you could easily kind of have one reference to the range of routes here and another reference to the range of routes there. But again, if you have the reference just in one place and everything else, builds off that name and that name, then you can change things in one place and have it flow down. But where that really comes into its own is now I've got the two things that will be my Lambda arguments right here. And so if I want to take this and convert it into a Lambda, all I do is say Lambda, open brackets, and then way down at the end I'll need a corresponding closing bracket. And then I just want to take out the first two things here. These are the two things that will become Lambda arguments and make those inputs here. So I'm going to say my arguments to the Lambda are schedule, and debug. And then I just delete these. Or actually, better than deleting them, I should take them and put them down at the bottom. Get this out of the way. So so you take the names and you put them as arguments to the Lambda, and then you take the references for those names and you put them outside as the inputs to the Lambda, and then you just delete this. And that's it. That is all. Because you had the let set up the right way, that's all the work to convert the let to a Lambda. And so I can press enter, just shrink my gigantic formula bar for a sec so we can see that it has indeed worked. And then the extra twist here is if I put this in square brackets, I should be able to make debug an optional argument. And then I'm just not sure if I've written it the right way around for the default to be yes. So then now I've got a Lambda of one mandatory argument and one optional argument that does all this stuff. And then I can take all of that, copy it, and I'll just call this new can-dist calc and paste all that in there, say OK, close. And now I can do the thing that I wanted to be able to do before but couldn't, and say new can-dist calc of just the one argument. And that gives me that. And then I can say, wait a minute, no, I actually want to debug, add a 1 there or add a true there, or whoops, not a true 1, one or the other, but not both. And then it puts me back into debug mode. So that is a little bit about the joys of LET, specifically in terms of being able to collapse everything, but also expand it again. A little bit about writing lets that are easy to turn into lambdas later. And I think that's basically it. I think it is wisest to say I'm going to stop there. I'll just kind of wave my hand in the direction of the other topics that I would be talking about if this were a 5-hour presentation instead of a 1-hour one, which is the Lambda helper functions. It's like you saw me using byrow and bycall in the other formula over here. So it just lets you kind of grab a range and take the max of each. Sorry, I meant to do column. Take the max of each column in the range and things like that. This only recently just started allowing you to use native functions. So you can say, give me the sum of each column. You can say, give me the max of each column, or you can write your own Lambda and put it in here to do some more complex calculation, and it'll apply it to each column or to each row. You can do it as a running total. You can, apply it over and over again using scan or reduce. You can apply it to a whole bunch of different inputs using map, make array. There's lots of stuff you can do there. There's some fun stuff around, timing. You could use let to basically time your function by just recording the start time and then recording the end time and taking the difference and doing your calculation in between. And then there's all kinds of stuff that I debate whether I should call crazy or not, but it's certainly more complex around recursive lambdas that call themselves in their definition, and currying and thunks. And suffice to say that there's a whole world out there that we could go much, 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 much deeper. Oh, sorry, there is one last thing that I want to show you, just because it might be my favorite lambda that I've ever written. So I kind of showed you earlier, an example of kind of building a model up bit by bit. This is another one kind of inspired by an FMWC case of like trying to apply a cipher to input letters. So, you want to shift A, B, C, D, E, X, Y, Z along by 5 letters. So you can split it into letters, get the Unicodes of those, get the offset of those, like how many letters offset is it from A, shuffle it along, get a new code for that, turn it into a character, and then collapse. It's a lot easier for most people to kind of build something up like this, even if you're ultimately going to have it be a let. So like here's it as a let, all kind of done in one piece, but you might not find it the easiest way to write like that. So I wrote this this function called lambdify, where you can say lambdify of these names and these formulas, and it'll write you. So the output of it is a text string, which is the let that builds all of that up, including I don't know why there's not a line break there like the rest, but anyway, including the check option. So then you've got all of that, and you can say, okay, I want to output. I'm sorry, there's not enough room here to output the check, but you can output the check with all the interim steps, or you can say, as an extra argument, I want the first. You can put in a number here, and it'll say, okay, I'm going to turn that number of things into a lambda argument. So in other words, here I want input and shift to be my two inputs, and then it generates a lambda that takes input and shift and an optional parameter for whether to output the check or not, and builds the whole let and lambda. It's not perfect. It only works if you lay your model out in a certain kind of way, and every column has to be its own calculation. So like if I put a separate formula in each row here, it would not work with that. But it does make it a lot easier to kind of, rather than building a crazy let right from the start, to kind of build out piece by piece, column by column, in a way that might feel more familiar, and then just grab lambdify and turn it into a let or a lambda as you need to. And that, I guess I should, let me grab a quick link. I'm going to put a link to my YouTube channel in here, if I can even find my own channel. There it is, where I have a bunch of other stuff about, lots of this stuff, but including some videos about lambdify and a link to download any of my Melissa, I do not have a gist, actually, as much as I tell people that is the industrial strength way to share, but I do have a publicly shared, hang on, let me see if I can find the link for it quickly. I do have a publicly shared Lambda folder. So where is that? Or Lambda file, I mean, with some of my esports Lambdas. Let me see, where's my playlists? Here it is. All right, so this is, that is my Lambda playlist. Wait, what the, oh, stupid, sorry. That is my Lambda playlist, hopefully, just sent. And then somewhere in here, there's the link to, yes. So I've got a whole like YouTube course on lambdas. So that bit.ly is the link to the shared materials on that. I will say it's not finished yet because I keep getting distracted by other fun things, and especially now by the Excel competitions, because it's the busy season for those. But the stuff I have shared so far, including my set of lambdas and including lambdify, is all there. So by all means, go grab that. Yeah, that's what I've got. Any questions?
Thanks, Tim. That's awesome. One question that we do have in the chat here: are you able to share the workbook with us so that we can share a link to the attendees? Doesn't have to be done. Doesn't have to be done immediately, but if you can think about it, let me know.
Yes, I will probably share a slightly skinny down version because, as you could see, I was glossing over a lot of other stuff that's in there, but that's also stuff from my paid training. So hold on to some of that.
That's fair.
But yes,
we don't want to be stealing your
the
paid training, but if you could share us the examples that you used today, that would be amazing. So, awesome. Are there any other questions that have come in related to this stuff? I don't see any.
Looks like the playlist link did not go through. So hang on, try that again. This is the Lambda Playlist. Playlist, I can spell. Boom.
Perfect. That one looks like it came through. I see an image on that one. So awesome stuff. I listen, the debug thing, that's wow. I have not seen that before. That was cool. So
it's the way to do it. Best of both worlds.
Now I got to go back and I got to try playing around with this again. You give me more work to do. So thanks for that, I think. So any other questions from anybody that they want to ask? Now is the time before we wrap up for the day. So yeah, go ahead, Sila.
Hello, everyone. Thank you, Dame and Ken, for putting this together. It was great. One question, maybe for both of you. Has any of you come across a way or a tool that allows us to do the auditing for one of the cells of a spill array?
No is the short answer.
Yes, I think so. Charles Williams has something that does some of that. He's got a Lambda helper thing, and I'm pretty sure that it also Explorer? Lambda Explorer. I believe that also does look inside the arrays as well. I haven't used it a lot, so I can't say for sure, but I'm pretty sure that's one of the features of it.
I
don't think so.
That's not.
No?
So I guess let me play back what I think you're asking. So you're saying like sort of the equivalent of the kind of audit formula step, like the formula auditor pop-up for a single cell from within a dynamic array rather than auditing the entire thing, right?
Yeah, so when we are working on using the traditional formulas and traditional way where we repeat the formula in each one of the cells and drag it down and across, we can click the formula in that cell and we can even see highlighted the cells where, if they are in the same sheet, of course, and we can see which cells contribute to that result. When we have a spilled array, we have only one formula living in one cell. If we click in any of the resulting spilled array cells, we get nothing out of there, right? But I've heard the struggles for auditors to have a way of, okay, where is this number coming from and which cells contribute to that final result for that particular cell.
I mean, I will say it's. So short answer is I don't know of any good way to just do it. For what I would think of as like simple dynamic array calculations, it's usually easy enough to kind of look at the anchor cell and kind of see, okay, so this is pointing to this array and this array and this array. So therefore, whatever row 7, column 5 of that must be pointing at row 7, column 5 of that, and that. But there are ways to make formulas that are way more complicated than that, where it's not just a straightforward correspondence of, this one is based on this one and this one, and where, the value that comes out in one particular cell might depend on the inputs, but also on 7 interim calculations from other places within that dynamic array. So I'd be surprised if there is a good general solution. But I think you can go a good chunk of the way toward it just by, basically getting a good sense of basically kind of parallel build of, here's the dynamic version and here's the traditional version. You'll get a sense pretty quickly of, okay, so if this one is pointing at this and I'm in the 7th column, then I must be, the bit for this column must be pointing at this cell from that, or must be pointing at this row from there. But it is pretty manual.
Yeah. That's my impression as well. I just wanted to check with you guys if you have come across something different.
See, I'm sure I saw something from Charles at one point in time where he was able to actually step through each step of a dynamic array formula and show what the values were and the calculations were in there, though. Yes, I don't remember which tool it was.
So it does do that, but it does it for So like, so if you
For the
have like a
whole array.
recursive calculation,
Okay.
it'll show you each step, but it won't show you, what happens to this one piece,
Okay,
or what drives that one piece.
gotcha.
Yeah.
Okay, fair enough. Fair enough.
Yeah, I do use his add-in, and it's really, really good. And also Monkey Tools, of course, for the Lambda sharing. It's my
Appreciate that.
favorite. My favorite method.
Plainly need to get Dim to install that because
Yeah.
so,
Yeah, because-
we'll
because-
talk offline, Dim.
Yeah, it's
Um,
just an easy way to put it across all the workbooks. Yeah.
I like it. It's a right click and inject your stored Lambda into your workbook, and it's done, and the library goes with you everywhere. I don't have to open any files. I don't have to download it. It's just there, which is sort of the point of it. And it works in a free version. So, hey, Dim, I do have one more question here. Scott's asked, with enough use, do you get fast enough with Lambdas to use for quick ad hoc solutions versus quick and dirty simple formulas, or do you reserve Lambdas for repeated use situations?
So a couple of answers to that. I mean, the short answer is repeated use, but with the Lambda helpers, so like the biro, bicol, map, scan, reduce, two things. One is there are things that I am now in the habit of using them for because it's easy. It's like, whatever, if I've got an array of values, I don't know, revenues by product by period, where before I would have gone to immediately below the leftmost column and hit alt equals to sum it up and then copied it across. Now I would find it easier to just type equals bicol sum, which is not technically using a Lambda, or it's using a native function Lambda, depending on how you think about it, but it's using the kind of Lambda adjacent stuff. So there are things like that I find faster to do it that way. There are also then, on top of that, there are things that not so much are faster, but things that you can only do using Lambdas. So like there are things that you can do with map or with scan or with reduce and a simple Lambda that would be very hard, or in some cases impossible, to do without them. And so for those, like, I wouldn't write a Lambda and put it in the name manager unless I thought I was going to reuse it, because that feels like somewhat onerous. I would probably just keep it as a let and copy it and move it wherever I needed it if I was just doing something ad hoc. But I would use a Lambda as an input to like a scan or reduce or something like that, even on doing quick calculations.
Cool. All right. I don't see any other questions in the chat at this time, so I think we'll wrap it up for today. Dim, thanks for coming and doing this. A fantastic presentation. Really enjoyed it. And for everybody that's watching, we will get the video posted up in the next 24 to 48 hours. Again, I'll post on the Meetup site when it's available, so you'll get a notification there if you RSVP'd. Elsewise, if you've already subscribed to the SkillWave YouTube channel, you get notified immediately when it's live as well. So thanks everyone for coming. Don't forget, we got a couple of meetups coming up in the next couple of weeks on Power BI, and then our last one for the year on Excel with my friend John. Outside of that, have a great one. We'll see y'all next time.